With emphasis on SDI. Software-defined infrastructure applies to compute, storage, and the network within a data center and in the cloud. This market segment is experiencing tremendous growth and innovation. It is facilitating increased agility, flexibility, and operational cost savings for enterprises and service providers. The first step in SDI was compute server virtualization, and that's now mainstream. As you know, Amazon Web Services is dominating the cloud computing space. And network and storage virtualizations are the current target areas. And you would have heard about SDN and SDS. They are the most popular acronyms. SDS stands for Software Defined Storage, and SDN stands for Software Defined Networking. Most of you guys have attended the previous month's SDI Conference. And now we are being overloaded with this software-defined related terminology. So SDS also stands for software-defined security. And on a lighter note, who knows, people may come up with terminology called SDH, software-defined human. Okay. So social networking sites and smart devices like smartphone, tablets are generating humongous amount of data. This needs to be stored efficiently, and networking plays a key role in moving data from one location to another location. And more of this data is being handled by public clouds like Amazon Web Services, Rackspace, Microsoft Azure, Google App Engine. And traditional data is not planned for cloud computing multi-tenant architecture. So we have highly accomplished panel members today to address on the topic. So the topics that they will try to address are where they see the growth, how companies will make money in SDI space, how SDI is driving economic development. IBM, Microsoft, Cisco, Oracle played key role in enterprise market. Some of our panel members have worked in these companies, so they can give their perspective in terms of working in an enterprise large companies versus startup company. And which companies will play a key role in SDI space? Will it be startups or incumbents? Since we have a lot of ground to cover, only 1 hour is left, I'll be asking one question to each of the panel members, and then after that I'll open it up to attendees. And thank you so much for your cooperation. So now let us hear from Deepak, Jeevan, Kumar. Deepak is principal at General Catalyst Partners, and he also worked at Sun. So Deepak, we would like to hear from you about the opportunities and challenges in SDI space.
Can you elaborate your question further?
Yeah, so basically what are the new opportunities in SDI space, software-defined infrastructure for startups?
For startups. Okay.
Yeah.
Yeah, so you were talking about, thank you for having me here. It's great to be on the panel with everyone here. Hold it closer. Closer, okay. Is this better? Yeah. Okay, great. So I think you're talking about the different layers, right? Compute, storage, network, and network falls into 2 major buckets, which I'll go on. And security as well, and then the management and orchestration layer on top of all of these. So I think there are opportunities in most, but not. There are opportunities in most, but not all of these. I think the biggest opportunity is when we look at this landscape, we feel that most of the compute pain points have been solved. Storage partially, but not properly. Networking, what we have, especially at L2 to L3, is being solved. L4 to L7 services and networking are still quite far away from being solved. And the main reason is that people haven't seen those pain points yet in L4 to L7 services in a dynamic cloud software-defined world. And people are just starting to see that now on a large scale. The security piece is also a pretty big piece that needs to be solved, as VMs are going up and down in a few seconds. The management and orchestration piece will still be a big place. So if I think about the addressable market in each of these spaces, the storage piece is easily 10, 20 to $50 billion in the software-defined world. per year for startups to address. The L4 to L7 networking and security piece is probably another $10 billion a year market that can be addressed. I'm talking about a long-term time frame here, not the first 1 or 2 year time frame here. Which basically means that if you add up the market cap of all the big players in these areas, you can see a few billion-dollar companies that can get disrupted and that can get created in the process as well. I would say that the most invested and the most underinvested and the most innovated space would be layer 4 to layer 7 network and security services at this point in time. We are open to investments in that space.
Thank you, Deepak. So next speaker will cover on the topic SDS, software defined storage. How many of you have read the blog that was written by Dheeraj on SDS? I did send it as a URL. Oh, cool, man. So now let us hear from Dheeraj Pandey. Dheeraj is CEO of Nutanix and also founder of Nutanix. As I told you, Nutanix provides a SAN-less virtualized data center platform. Nutanix has been growing at 100% quarter on quarter for the last few quarters, and they have reached $80 million last quarter. So if anyone wants to join or want to talk to Nutanix to explore some new opportunities, Dheeraj is here. So I have been trying him to come to our events for the past 10 months. He is a very busy person. So please take the opportunity to interact with him after the panel discussion is over. So Dheeraj, what industry problems SDS will have and where will solve, and what are the current problems and what it's going to solve, and who will play a key role in this market, like startups or incumbents?
Thanks, Sridhar. First of all, thanks for your tenacity. I know the last 10 months there's a lot of travel that happens as you build a business, and my schedule was always like that. So I appreciate your tenacity, and I really am humbled to come here in front of a very august alumni here to address people. Not to say that I know a whole lot about building a business, but definitely if I can help some people, convince them to start their own company, then I would have done my bit. I think it's off topic. I would say that starting a business, people like us, the place where we actually just get a little bit more than others is we take the first step. So you have to take the first step, and then good things will happen. So that being said, come back to your question of software-defined storage. We've looked at storage for the last 20 years. It started with server-attached storage with the Unix LAN. It was big Unix servers having that storage to them, and then moved away from that into a central storage architecture, a hub and spoke architecture, where storage with the hub and then spokes with the servers, and you would actually fetch data in hub and spoke model. And the last 15 years, and that's the way things have been. But then came virtualization, and it basically turned everything upside down in terms of not just performance, but price performance and scalability, and the idea of dynamic virtual machines and dynamic data centers, and managing storage at the level of virtual machine. A lot of things were just upside down. When we tried to retrofit the old SAN model, or the old network storage model, into this new world of virtualization and cloud computing. But people are mostly thinking about virtual machines, and they want to apply policies on virtual machines, whether it's high availability or RAID or GR backup or snapshot or clones. They all want to do things top down. They're starting from the application to a virtual machine down, as opposed to thinking of volumes and LUNs and things like that, protocols and stuff like that. Which in the old world of physical servers is okay, but in the world of virtualization is totally broken. So the idea of software-defined storage is that just the way we virtualized compute and virtualized memory and virtualized networking, it's time to virtualize storage services, and let's bring it back into the server, and now we have a very homogeneous architecture where on x86 servers you can run everything. You can run business applications, you can run storage controllers, you can run WAN accelerators and virtual firewalls and virtual load balancers, everything becomes virtual. And storage is just yet another virtual service that runs on top of a hypervisor. And it provides a lot of value. I think for one, it makes it scalable because we have taken this hub and spoke architecture and you kind of disaggregate the hub so it becomes a peer-to-peer architecture where in every server you can have a storage controller attached to it. You can have these storage controllers talk to each other, fail over to each other, spill over to each other, and so on. And the fact that it's all a virtual appliance now, you can go and orchestrate, manage, and provision at will without having to have people go in and physically rack and stack something. Also, storage comes close enough to compute so you get better performance advantages. And I think the most important thing, which I've actually said before, is about this whole idea of decoupling mechanism from policy. If you look at the old generation storage, they basically shift from the factory policies. They would say, this is a RAID 6 machine, and by the way, it's dual controller machine. So everybody gets RAID 6 and everybody gets HA. When you really wanted to do this post-deployment, you can pick and choose the virtual machines that wanted RAID 10, some wanted RAID 6, some wanted a different kind of RAID feature. Some did want high availability, others didn't want high availability. So everybody really wanted to do things at VM level, and the folks from the factory, the old world, was shipping things, but policy was early bound as opposed to late bound. So one of the biggest strengths of doing anything software defined is the ability to decouple mechanism from policy. You factory ships with mechanism like RAID, like high availability, like clones and backups and snapshots, and then the administrator applies the policy on top of it. So it's a very powerful concept. It's been used in systems design for the last 20 years very effectively in the world of Unix and systems, operating systems in there for a long time. And I think it now comes to the world of data centers in a pretty big way. So we're very excited about the idea. And I think the challenge about anything software defined is how do you produce a product that's imminently consumable? Because one of the challenges a lot of the SDN startups are facing today is that they're thinking about something that's extremely large, a top 5 cloud service provider or a top 50 Fortune 50 company or something that has tens of thousands of switches, and they need to bring all of that in virtual storage, network SDN controllers and things like that. All of a sudden, you're building a company which is extremely rare air. It's all about very niche use case, which is top 5 companies, top 50 companies, when you really have to build something that's imminently consumable, which is something that the mid-market can use, a small school district can use, a hospital can use, a law firm can use, and all that stuff. So that's the challenge the SDN guys will face to really build a very large multi-billion-dollar company. Is how do you make something easily consumable? And I think that's true for software-defined storage as well. How do you package it? How do you distribute it? Because technology is one piece of it. There are other pillars in building a company as well.
Thank you, Dheeraj. So next one, before I introduce the next panel speaker, I will be asking a quiz question. So how many of you have online bank accounts or brokerage accounts?
Yeah, everybody.
So here we have a panel speaker. Without you knowing, every day you touch his code. Like he has written very efficient Solaris code, and like most of the financial companies run their boxes running on Solaris. So can you name the panel speaker? Yeah. Okay. So Sunay Tripathi. So I had the privilege to working with him at Sun. He has written very efficient Solaris networking code, and today it keeps running in most of the financial companies. So now let us hear from Sunay Tripathi. Sunay Tripathi is CTO of Pluribusnetworks, and he's also NIT Allahabad alumni. Sunay was chief architect for network virtualization in core Solaris. Sunay, what is the secret sauce of Pluribusnetworks compared to the other SDN startups which are out there?
So, Sridhar, thanks for getting me here. And Sun is dead, so let's forget about Sun microsystem. The interesting part here is, if you look at it, it's all about merchant silicon, right? I mean, you have Intel and Broadcom building switch chips, third generation, very powerful. What is the OS that drives them, basically, right? So the success of Pluribus is that we approach the switch chips just the way typical Unix would approach x86 processor. You know, you have caches, IO controllers, memory controllers that are all managed by the OS. And then on top of that, the OS itself doesn't do anything. It's the app running on that OS that does something. So we build a distributed network OS. The goal is to understand the switch chips just the way you understand the x86 processor, right? And networking world is a bit different. You deal with L2 tables, you deal with TCAMs, you deal with security, you deal with pipelines and policies and stuff like that. And the biggest thing you deal with networking is the distributed nature of networking, right? A single switch by itself is very uninteresting. It's a collection of switches. So from day one, what we build is a full-fledged network OS that understands these switches. It's distributed, fully peer-to-peer, and can scale to whatever nodes necessary. But reality of life is typically, you know, you want to be able to run in a typical data center, 10, 20, 30 racks, and add machines as needed, add racks as needed, right? So it's a horizontal scale model, no centralized core switches and aggregation switches in that world, just top of the rack. So, and the goal here is to allow people flexibility to connect whatever way you want, right? I mean, you don't want to know if you're introducing loops, you don't want to care about where you need bandwidth, you should be able to use software to see it all. So as OS, that's what we're doing, right? That allows people to build applications on top. That's why he's my good friend. He's going to invest in companies that are going to use my OSs, basically, right? So when it's ready.
When it is ready. It is, I can promise you. Like you yourself said that, right? The L2, L3 problem is solved, right? I've done my job on it.
I think it's mostly being solved.
It's mostly being solved.
By really good startups.
No, so that's the key to Pluribus, right? Build something that people can use. And it's software.
Okay, thank you, Sunay. So now let us hear from Prasad Vellanki. He is the CEO of Convergence and also IIT Alumni. Prasad, can you inform attendees how networks and network services will be delivered in software-defined infrastructure as edge networking is moving towards the host?
So, I think Jeevan kind of enumerated some of the things. So, can you hear me?
Yeah, close to the mic.
Yeah, so what we feel is if you, as applications get, we're looking from how applications get delivered, right? And typically in any environment. It's not just wiring the network, right? You can basically wire a switch and then connect a box, a server box to it. It's beyond that. So there are a lot of things which needs to be deployed when an application is deployed. For instance, if you deploy firewall, you need to deploy some level of load balancer if it happens to scale. And then you need to deploy some level of IDS to have security, right? And on top of it, there's logging and all kinds of things that needs to be deployed. So the problem of network, when you say when you deploy an app in a scalable manner, now translates to not just wiring but beyond that, right? A lot of innovation for the past 2 years or 3 years have gone into virtualizing the network as being at that level, at L2 level, right? I take L2 packet, put it on L3 and then kind of shut it down, right? And typically that's the typical approach. But people have not looked at, okay, now how do I deliver the services in the same frame? So that's one. The second part is, I mean, if you look at these services, over time, they've started, the way initially they started implementing on a custom chip, but last 15 years, they've gone to kind of a server environment. If you open a box, they are servers, right? And there's software running on servers, right? Pretty much that's been the market, or that's been the technology. So now, what's happening is, in order to scale, then the next problem is people said, I need to scale this, right? I need to scale it. How do you scale it? People have started saying that I need to buy a bigger box, right? So there is a whole notion of the scalability comes into picture. There's always this 10% of the market which buy the boxes at bare metal, do it, But that's, I believe the 90% of the market need 10% of the features, but need some level of elastic scaling. So there's a problem of elastic scaling. The other problem is, one of the things is, as the previous generation network architecture is all about a lot of these boxes residing at home, right? So therefore, if you need a virtualized environment, particularly this kind of accelerates or it shows the problem. The traffic also has to hit the core and come back, right, all the time. So in a virtualized environment, especially your multi-tenancy, you don't want to where you can take the decision where in a local area, like in a top of the rack switch, or particularly all the edge switches, you can take some of the decisions there. So therefore, a lot of distributed nature, things are going to move towards a distributed nature, right? And the third part is, as applications get deployed, particularly the private cloud or public cloud, whatever cloud, in whatever area, you need to make sure these services reside closer to that, to at least reduce the traffic across the thing. So therefore, the proximity of these services residing closer to the application becomes important. Now, that's the third part, right? Therefore, now the problem space is now looking at the infrastructure, solving these problems effectively in a platform, right? In a network, what do you call it, network controllers, network is distributed platforms, right? So that's where I think the innovation is going to go into. So I think it's not going to be like making a better load balancer or a better firewall. It's about better scaling, better optimization, better scale out, right? So a lot of the customers we talk to, or the potential customers we talk to, looking at saying that how do I elastically scale? Because I don't have the traffic today, but I have it in a month, or I don't have it in a month, right? That's one part. The other part is I want to deliver the services faster, right? I don't know whether the services are going to be successful, but I do want to at least invest some part so that I can deliver it faster. So the agility of delivering the services is also key. So these are the architectures which we are looking at, right? So what we are focusing on is around the layer 4 through 7, but not delivering the layer 4 through 7 as a functionality, but looking at solving the problems of agility, scale out, right, and optimization, those kind of problems, right? So that's basically what we're looking at. And therefore, I believe that is a problem which needs to be solved, and I believe that's where the market of network virtualization actually going to mature, once you solve both the network and the network functions of network services virtualization. Right?
So thank you, Prasad. So if you guys want to join his company, we already have an alumni who's already working for Convergence. His name is Subramanian. I think he's here today. Yeah. So now let us hear from Srini Gurrapu, CEO and founder of InnovationZ, and he's also a NIT Warangal alumni. So by the way, Srini was my lab mate for almost 4 years at NIT Warangal. So surprisingly, we have our third lab mate also here. So Srini, Srini is also here. So Wheels Innovation is building app to cloud secure services delivery platform to address the BYOD and BOS trends. And I'll be asking 2 questions because I have been asking a lot of questions to Srini when he was my lab mate. So let me ask him a couple of questions now. So how does SDI, SDN, SDX affect the transition to mobile devices and cloud? These are 2 dominant trends right now. And the second question is, what are the security ramifications of the shift to SDI and SDX?
Well, thank you, Sridhar, for being a lab partner there, and that's a privilege, and that's also sometimes not so privileged. So we actually look at the SDI slightly differently, and from the time that I had the opportunity to work at Blueboard, where we built the proxy appliance and the near-to-rest and Juniper, we always looked at the infrastructure as comprising the 2 ends of the pipe. We not only just focused on the data center. Data center actually delivers your business service, but the business service is only meaningful if it's actually consumed by an end user from certain endpoint. So when you're talking about a business or a business service, you need to focus on the end-to-end service delivery. So when I look at the infrastructure, I actually look at from everything from the device to the data center. So that's in the old world. as we are moving to this new world of mobile devices to the cloud, we look at the infrastructure being something that transcends, that actually spans from the mobile device and into the cloud. And that service could be hosted in a private cloud or the public cloud. And even in our world, we believe that infrastructure is just a compute facility. Whether on the end user side, this could be a mobile device that you bring in, or on the other end of the pipe, on the data center, on the cloud side, you have compute storage and the network. But what is actually more meaningful from an organization and business standpoint is about the service. It's not about open flow, or it's about the package or its stuff. It's about the services that you're delivering. Am I delivering the CRM, the Salesforce service? How is it being delivered? Is it being delivered with the right security, right SLA? When the people use that Salesforce service, from a Salesforce CRM app running on my personal mobile device. So that, I believe, is the next frontier of what is going to happen in the SDI. Today we are actually building the building blocks of getting the VMs provisioned, getting the storage provisioned, getting the L2 and L3 provision, so on and so forth. But once we have all those building blocks in place, I think we're going to move into more of an end-to-end service provisioning from the apps. And again, it's device agnostic. It's from the mobile apps connecting to the cloud business services that are either hosted in your private cloud or in the public cloud. What we are doing at Wheels is actually putting that overlay network. From your app connecting to your business service that could be running. That could be powered by some kind of an SDI infrastructure that's running in your private cloud or public cloud. But our focus is to, enable, put the infrastructure that actually allows the services to be delivered with the right security and SLA. And I want to echo Deepak's comments. Today most of the action, as I said, is in the L2, L3, and the compute and so on and so forth. When you're a Juniper, what we realized is the networks, when you're only processing the flows and the tables and the routing tables, they're nothing but dumb pipes. They're connecting people. Just connecting people does not really do much. It's only when you actually understand those flows and map it to some kind of business services. This is a CRM application, and that needs to be delivered to my salesperson with these kind of services and this level of service level. That's what, when networks can actually enable you to do that, then networks are not just dumb pipes, they're actually service pipes. So at Juniper, we invested a lot of resources in coming up with how to bring that entire intelligence of application, user, and so on and so forth. But at that time, it was just a vision. And what SDI allows us to do that is to actually deliver this intelligent services, from the apps to the cloud, much more dynamically and with much more in agile fashion, and also with reduced cost. So I think that's the shift that's happening, and we are doing our bit by providing that overlay network. To address your second question about the security ramifications of SDI, and this is unfortunately one of the biggest disappointments that I have. When we were building the internet, security was always an afterthought. In fact, we would just build the switches and the routers, we connected the people, then we figured out that, hey, we need to understand the application, then somebody built an IDS, somebody built something else, and so on and so forth. And now when we are moving into this SDI kind of an ecosystem, unfortunately we are again reliving that entire step-by-step evolution. In fact, I wish we could have actually built all this foundation with layer 7 intelligence right at the top. Today, one of the biggest issues, in fact, in all the customers that we talk to, moving to the cloud is appealing from a cost-saving standpoint, but the number one reason why people are hesitating to move into the public cloud is security. Cloud security is the number one concern. And we are also living in a world where the trust has actually moved into more like an explicit trust. In other words, the biggest threat factor is inside. So if me as an organization, if I go sign up with Salesforce.com for my CRM, the biggest issue that everybody is concerned about is, can I actually put all my customer data and their personal information on Salesforce? then what about the people that are actually administrating the Salesforce.com database? It's all about the insider threat. If they have access to the databases or something that is powered in the Salesforce.com, who is going to guarantee the security? So now everybody is like, hey, let's all move to the cloud, but is my data, just by putting it in the cloud, is it actually secure? So there is just a lot of focus now being thought through on is moving to the cloud, what are the security ramifications, and allowing people to use their personal devices, what are the security ramifications. So the security paradigm is changing where is into more like an explicit trust model. In other words, you don't trust the device or you don't trust the infrastructure. But yet, you are responsible for protecting your own data. So that's basically the ramifications that we are having, and that's where companies like Cypher Cloud, where you're trying to tokenize every data that gets stored in the cloud, and on the devices, we have all this container and the proxy solutions and so on and so forth. Ultimately, it's all about application intelligence, and you are responsible for your application and the data security, and that's not something that you cannot really do that at the infrastructure level right now. But what I see is going to happen is the SDI evolution, where the storage will have an embedded security, or the compute will have an embedded security, and the networking will have an embedded security. So that security is not an afterthought, but it's actually part of the ecosystem right from the top.
Okay, thank you, Srini. So now I open up questions from attendees. So we'll be asking the first question.
Actually have two questions. One for Sunay. Did I pronounce that correct?
Yeah, you
okay,
did.
Sorry about it. Can you add a little bit more color to the network OS that you mentioned? I mean, in the sense that how does it compare with Brocade's Ethernet fabrics, or Juniper's True Fabric, or even the OpenFlow, and how does it differ the OS that you guys are doing at Pluribus? Thank you.
Is this working?
Yep.
So, the interesting part is when you say Brocade OS and Juniper QFabric OS and all, if you look at the delivery mechanism of these OSs, it comes in a crate. It's a large piece of sheet metal and costs about $100,000 or $100,000 or so on and so forth, right? But a real OS, you should be able to download it, right? And it really should be supporting applications, right? The goal of the OS is not to do something by itself. The goal of the OS is to support applications, right? The goal of the OS is my consumers are people sitting next to me, right? So the part here is that, at least for Pluribus' point of view, we left the chip design to Intel's and Broadcom's of the world, basically, right? They are designing chips. They design very good chips. They spend billions and billions of dollars on these. They are delivering switch chips which are on third generation, and they have APIs which are very, very open APIs. So our OS, from network standpoint of view, goes down the path of understanding these. I think out of battery. So our OS goes down the path of, can we make, what do we deal with in the networking space, TCANs, IP addresses, MAC addresses? Can we make them the default types for the OS? Can we allow application writer to deal with these as native types, basically, right? Just the way you deal with integer and longs and so on and so forth, right? And then the part is the network by itself is distributed in nature. It's not a single device. So does the application writer has to understand that? Or can I hide that from him in abstractions, basically, right? So the application writer can deal with application as an OS, as an abstraction, network as an OS, as an abstraction, and say, hey, I want my network to do this, right? So my simple test for people who say they have a network OS is, okay, give me an IP address so I can log into it, right?
can I log into your network OS? Where is it? And typically they give me a switch IP address or router IP address. I'm like, no, that's not the network, right? So that is, I think, where we are very different from the old school world of, Juniper Q fabric or people building fabrics. Because these are all hardware fabrics dealing with connectivity and protocol. OpenFlow is a protocol. It doesn't do anything by itself, right? It's something that consumes that protocol. It's an application that consumes that protocol and an OS that connects applications to use that protocol. So that's how we are different, right? At the end of the day, it's open source OS. And at the end of the day, it's understanding the network at the level where typical server OS is developed. Does that answer your question? Okay. Yeah.
Hi, my name is Shashi. I have a question for you on the OS also. How do you compare your OS with what Cumulus is doing? They have a similar approach for doing.
So, I mean, we should probably get Cumulus here and ask them.
No, I mean, I'm sure you're doing.
It's not right for me to talk about something else, but from what I understand, Broadcom tells us that Cumulus takes their SDK and ships it out to customers in Linux, basically, right? So at the end of the day, it allows someone like me to build something on top of what we're building right now. But my problem with Broadcom was that they build very good SIG. In terms of software, we have a little bit doubts about their capability, right? So I don't want to take their software, basically, right? It doesn't matter if Cumulus offers it or they offer it. So typically, the whole concept of SDK, which is like, I got a library that I got to use and linked against and whatever. It's not really an OS paradigm, right? It's not a native. Going down to I'm guessing you understand operating systems, right? I want to go down to the system level. I want to go down to the OS integral types, basically, right? I want my x86 register to understand the IP address, basically. So that is where, this is what I've done all my life, basically, build OS to support people's application. And that's what we're doing to get a load balancer app, for instance, to come on the network switch itself and say how I can make advantage of that. Or talking about what people were saying, security is missing, right? So we become a platform for security because at the end of the day, we are the switch. You can see everything in the network using the OS, and I'm not going to build that app for you, right? But I'm going to give you APIs to say, hey, I want to see every TCP SYN packet, right? And by the way, I'm going to make a decision whether it goes through or not, or where it goes through, right? And I'm going to write simple C code. And by the way, it doesn't matter which switch I run on, I want to see the packet irrespective, even if it's not going through the actual switch my code is running, right? Because network is a network, I want to see it across them. So those are the kind of things we do, basically, right? I mean, this is, again, 2.5 million lines of code, and 3 years later, that's what we have achieved.
Hi, this is Barney. I'm from Juniper. This question is to Mr. Prasad. So the question is about specific to data centers, and we have read some reports that 80% of the traffic in a data center is east-west. So what about this 80% of the traffic is east-west? So what about the services, network services like load balancer, security, and anything else? Are they geared to north-south traffic, or what? How much of it is needed for east-west traffic as well?
So if you look at the current architectures, right, that is the data centers as they got built, typically all these load balancers and the firewalls reside in front of the application. And once you hit that, they go to the application, right? And depending on what the architecture behind the application says, you could have a network service or you may not have a network service, right? So therefore, the east-west traffic you're talking about is between the web servers to app servers to database. Right? So So that is right. That's in it. But what happens is now that is in a very monolithic fashion the way the applications are built. Once you go towards more where I'm going to do a self-service networking or a self-service cloud, right? Whether it be public cloud, private cloud, right? Now you don't know where a typical server is, and you don't even know. And if you go with the traditional way network services are built, they will be built at the core, right? So everything hits that and goes to a particular thing and then comes back. Now if you need to go elastically scale, the northwest, I mean, you need to keep coming back to the core for a lot of these services, right? So that's one of the problems which will happen. So therefore, there's going to be a migration of taking from the core and moving towards the edge, right? So the services, just like the switches move from the top of the rack, at least in the current generation, right? In the future, maybe they will go back to the top of the rack, but at least the edges move to the server, right? I mean, it comes in different forms, like V-switch and multi-switch, or whatever. The edges move to the server. Similarly, we believe that the services will start going towards the edge, right? Now, the second part of that is the scale, right? Now people are demanding on-demand scale, right? Like I want to basically not build for 5 years, not buy for 5 years, but build as I go, right? Therefore, now in order to solve that problem, people have started looking at elastic load balancer, right? Or elastic star, call it elastic firewall, elastic load balancer, elastic SSL service, whatever it is, all the big elastic, right? So that's that part. Now again, once you make that and you put into the network architecture, so that problem needs to be solved. So we believe that, so therefore, for what happens in the core, we start moving towards the edge, right? The network services. So I don't know whether I answered your question. What I'm trying to say is, where typically in the current generation, as they move to the cloud, if you basically implement the way it is, the north-south traffic actually increases because you need to go back and forth between the firewalls, right? Between the services. Now, therefore, because it's all, I think there's going to be more east-west again, but it's going to be solved for the networks in different, right? It will be more distributed, it will be more, right? So it will be more elastically scaling, those kind of things at the infrastructure, right? Whether it's going to be solved at the edge, it's going to be top of the rack, yes, that's going to need to be seen, but yes, that's basically what it is.
So any questions on DC topic, storage, security? Yeah.
So by the way, my name is Amar Urkuru. I work with Tintri right now, and I just want to add a little bit. I mean, this question is for Dheeraj. I actually worked with Sun for 2 years and the HBA drivers, the HBA storage division. And then last 11.5 years, I worked at Brocade, working in the storage networking, Fabric channel, and also Ethernet fabrics. And now I moved to the array side, storage array. Every time I see a lot of challenges, and also those being resolved by some other new technologies or whatever. But in the last decade, because of this server virtualization and also the requirements for agility and elasticity of the data center infrastructure, there are a lot of buzzwords now. There's already server virtualization, like you mentioned, it has become mainstream, and there is some momentum in SDN, and also there is some, I would say, some momentum from SES, either from incumbents like EMC or startups. But my question is, looking from Nutanix and also primarily, do you think that this SDI is going to be also again like a quick fad that is going to die soon, or do you think this time there's going to be some reality that we might see in the next few years?
Well, there's always froth when you have a new term that is coined, right? If you go back in time, even for example, big data has a lot of froth attached to it. Cloud has a lot of froth attached to it. Mobility has a lot of froth attached to it. And, software defined has a lot of froth. So every term has a bunch of fraud attached to it. A lot of it because, and I wrote this about this in the blog as well, is because the big guys, when they go to the Wall Street analysts, they need to prove that they're innovating. And the analysts will ask basic questions. What are you doing about software-defined data center? And they need to have an answer. Now, whether or not it's delivering any revenue to them is a secondary, thing. But the most important thing for them is to keep proving to the analysts so that the analysts can continue to say, look, innovation is still happening at X, Y, and Z company, and they continue to innovate in this and that and so on. But we all know that most innovation happens in smaller companies, and the big guys just acquire that innovation. It's just the order of the day. That's the way the risk-reward equation is actually written, because basically innovate outside and then go and acquire this company. So I think a lot of the fraud is attributed to the big guys, and simply because they have to protect their turf. They have to talk something when it comes to Wall Street and so on. Now, that being said, every time there has been an innovation, it has helped us all. Whether you look at the 80s, it was about client server. Client server, I'm sure, had a lot of froth, as had the idea of internet and e-commerce. There was a lot of froth back then as well in the world of e-commerce. I'm sure there was the same thing that happened with virtualization as well. There was a lot of froth. As part of the froth, Citrix made a $500 million investment in virtualization. And it went nowhere. They bought a company called ZenSource, and they didn't make a single dime out of that $500 million investment. But it helped Citrix's stock for the next 3, 4, 5 years. They were always spelled in the same sentence as VMware. VMware Citrix, right? But we cannot deny the fact that virtualization helped a lot of companies. We can't deny the fact that e-commerce helped a lot of companies, and internet helped a lot of us as consumers and business users as well. So I think this whole space of software defined, there'll be a lot of froth, but there's a lot of good things that will come out of it. We'll actually move towards decoupling mechanism through policy. We'll make multi-tenant services possible. We'll postpone judgment in terms of how to really manage data centers till the very end, and try to apply these policies to software, virtual constructs like virtual machines, virtual switches, virtual ports, virtual disks, as opposed to physical everything and so on. So there'll be a lot of value that will come out of it, but these things take time. And as I mentioned, my first observation, startups have to make sure they don't fall for the froth, because your biggest enemy is the froth. You have to figure out how to package your product in a way that's immediately consumable, and it has to solve today's problems with an eye on the future. So if you're just looking at the future and saying that's how things are going to change, that's a second-order business assumption. You're saying, well, when that happens, my product will become really big. But what about today's problems? 99% of IT is dealing with today's problems. So anything that you're building for the future has to solve for today's applications, today's use cases, just as well as it has to do tomorrow's. And I think that's one way to navigate around all the froth that's been created by the media. And a lot of the froth gets created because of a very impressionable media which needs a sensational story to write about. And none of these guys really go and kick the tires on the product. None of them, they just want to write stories. And the big companies feed them a lot of stories. Now, unlike the big companies, the startups don't have the luxury to feed stories because the VCs are watching all this. That's the only story they have. They better go and make some money along the way and have some milestones and checkpoints and things like that. So I think in the smaller companies, you'll see some more honesty along with do or die environment. In the bigger companies, it's like in a hookah bar, you actually pass the hookah. That's what software-defined mobility and cloud and all that stuff is all about.
Can I add one thing to that? What Dheeraj said is true, 100% true. There's other aspect why this can be rolled back. Because of human nature, and look at what the big guys want, what people want in general, is cheap, right? Things want to go cheap. And that trend, look what SDS and SDN and all these things are driving. What they're driving is making the merchant silicon prevalent. That trend you can't unwind out of, basically. So this has to go somewhere, right? we cannot put this genie back in the bottle where we say that big guys acquired all the companies which are making merchant silicon happen and actually are going to go and keep the costs and the market price where they were, right? That has to unwind. And that is unwinding as we speak, right? Look at the server world. I have sold $1 million single server, right? I have sold 10 of those units not too far back in 2002, right? And partied like crazy, right? Where there was no end to the world. That same machine is selling for $1,500 to $2,000 today, right? That trend cannot be rolled back. So when Intel and Broadcom and various other hardware companies, people who make disks, people who make switches, people who make processors, they are actually doing the grunt of the work and selling at $600 for each one of these things, or $700. Why is it someone who is just assembling them together charging $30,000, $40,000? What is the innovation they've done? Especially when they are going to the same place, which is China or Taiwan or wherever, and getting this built at the same price that you can buy. So something has to give. So apart from what Dheeraj said, there is really an underlying change here, which is people realizing that I really don't have to pay $30,000 for a $2,000 machine. There better be some value in it, otherwise I'm not buying.
One thing is, I never like this acronym software defined.
I hate it personally.
It is a very geeky stuff. It's about, and what it connotates is programmability. That's good for us and the technical people, but it doesn't have any business value proposition. A better definition in my view is SDI stands for Service Defined Infrastructure. And that's what, if I'm an organization, my job is, how do I roll out my, CRM, my email, and other business services, and then how do I map those services to the required infrastructure. And what software-defined infrastructure, in my view, means is, programmable infrastructure means it also gives me to automate the infrastructure that is needed to deliver the service. I think that business need has always been there. Initially, about 5 years ago, a data center guy, when you're trying to roll out some application, he had a label with a sheet of paper that said, like, this box at this location in this office would connect to this machine at IP address, and they had all these things, mapped out in papers. And then later on, we moved into, much better, addresses and so on and so forth. What virtualization has done is it allowed you to automate this, provisioning of these machines, much better. But then that's just one piece of addressing. And ultimately, what everybody needs is, kind of the business semantics, the service definition. Here is my Salesforce, and this is what needs to be delivered to these users, regardless of the device, regardless of what it is. The only thing that matters to me is who is the user, what service that they need, and here is the quality of service. I think that's the vision that we are all after for, and there is a real value to it. But the thing is, being a startup, like what Dheeraj said, we cannot go chase that vision. We need to be very pragmatic and focus on either one killer service, one specific value proposition, and go prove the value, and that gives us the real estate or the leverage to go chase that vision. And I think, I believe the vision in the service-defined infrastructure world, and the way we get there, we need to be laser focused, while the Cisco's and IBM's, they do the big talk.
Sorry, I have to kind of disagree a little bit. But overall, I agree in terms of the services being delivered and looking at a service architecture. But to me, which is software, or I call it programmability, comes from a different, it's about, I think, automation, right? Clearly, the last generation of things were not automated, right? Yes, they were building, you can go log into SSH, you can go in to do something and automate it that way. But if you really look at it, the world has changed from, if you look at the ops, the guys are, you look at the way the public clouds are run. They're run with a very minimal set of people. And the only way to achieve that is to kind of have people who can program and then automate that, and therefore you never look at it again, right? So to me, it's very important that programmability part of any service or network becomes very important. And therefore, I think that is an incremental evolutionary step, I agree on that, right? And that is the thing, that is the problem that needs to be solved today, right? Where you need to make sure you can automate it very quickly, and you also kind of solve the problem, what you call the DevOps guys, right? I mean, this whole DevOps movement happened in the last few years, right? And therefore, that's the problem we need to solve, in my mind. Yes, and on top of it, you can always later build this whole service-oriented architectures, but that's built on top. But you have to fundamentally, before that, solve the problem of automation, right? And that needs to be solved across the infrastructure. It's not just servers, right? So therefore, even the networking, network services, storage, whatever there be, it needs to be solved at that level. And that needs to be, that's where I think that problem needs to be solved, and that's the current problem that needs to be solved. That's what I think.
I think both are happening in parallel. Like,
We'll wrap up.
So let me give a very extreme example to help put a business case in mind here. So if I'm chief marketing officer of a very Fortune 500 startup, and I have a new project to analyze Twitter streams on my customer feedback and what people are talking about on Twitter streams. So I have two options. Option number one, I go and talk to my CIO office and petition for a new project, acquire servers, acquire storage, acquire network compute, get the programmers to write something on Oracle or SAP and like all different architectures, put everything together. Let's say this is a big project. It requires about 10,000 servers. Option number two is I go and use, let's say, business analytics on gooddata.com. I will go to market in literally few hours to few days, not few months. And that is the problem that the software-defined infrastructure world is to solve. Decreasing the time to market very, very significantly. It's not by a few hours, like by 10 times, because that is what public cloud services, be it at the infrastructure level or application level, are offering. And if you are able to do that, that is the success of software-defined infrastructure. There are two ways of looking at the software-defined problem and the agility and time to market problem. Either infrastructure up or applications down. And I think we have to know where the startup is playing and what exactly is the problem that's being solved. You can't solve all the problems at the same time. And if you keep that extreme example in mind that I mentioned, then you will understand why software-defined, programmability, agility, time to market, all that is important.
Okay, I thank all the panel members for giving very good insights on SDI. Please give them a big applause.